The purpose of this problem is to introduce the cross product between two vectors, actually just the computation formula. And the cross product of two 3D vectors is another 3D vector. And one way to compute it is as follows. So if we have the vectors u1, u2, u3, and we want to cross this with v1, v2, v3, the result will be another three-dimensional vector, which is formally given by this determinant. So I, j, k, u1, u2, u3, v1, v2, v3. Now, how do we compute this determinant? Well, the idea is that we're going to find three 2x2 determinants, and we're going to multiply I and then j and then k by these 2x2 determinants. Now, notice that there is an alternating pattern, meaning we have plus, minus, and plus. And in order to find those three determinants that we're going to put in there, what we do is we delete the row in the column that contains the corresponding vector. So if you want to see what goes in front of I, delete the row in the column that contain I. If you do that, then what do you get? You get this determinant right here. Take a look at it. If you delete the row in the column that contain I, you get this 2x2 determinant. And what is this 2x2 determinant? I remind you that a 2x2 determinant is computed like this. It's AD minus BC. So this is going to be U2 V3 minus U3 V2. Okay? And then here you will need to use your imagination a little more. So delete the row in the column that contain J, and you will get the determinant that has rows U1, U3, V1, V3. So this will be U1, V3 minus U3, V1. And finally, delete the row and the column that contain K. It's easier to visualize what, whoops, sorry about this. It's easier to visualize what determinant you're going to get this way. It's going to be this determinant right here, which is what? It's U1 V2 minus U2 V1. If you don't want to use IJK, but you just want to use the usual coordinates, then this is the same thing as U2 V3 minus U3 V2. And in the middle, you have U1 V3 minus U3 V1. And then you have U1 V2 minus U2 V1. Don't try to memorize this formula, just learn this process that was just explained, which is going to be pretty much the standard way to compute the cross product between two vectors. Of course, there are more properties to this product, but the purpose of this exercise is just to introduce it. And let's solve the specific problem by using the formula that we just explained. So for the solution, we want to compute the cross product of 1, 3, negative 2 with 2, negative 1, 1. And this is going to be I, J, K, 1, 3, negative 2, 2, negative 1, 1. And now let's see what goes into the first coordinate. So what goes into the first coordinate is really this determinant. Let's do it here on the side so that you can see it. It's 3, negative 2, negative 1, 1. Okay, which is 3 times 1, minus -2 times -1. And this is 3 minus 2, also known as 1. Okay? So what goes in the middle? In the middle, you have the determinant that you get if you delete the top row and the middle column, which is 1, -2, 2, 1. So this will be 1 times 1 minus -2 times 2, which is 1 plus 4, also known as 5. Now you have to be careful. In the middle coordinate, you have to put the opposite of that. So that's -5 right here. Remember this sign that we explained. Determinants are highly alternating objects. And finally, for the last coordinate, we will have 1, 3, 2, -1. This is the determinant that we get if we delete the first row and the last column. And this will be 1 times -1 minus 3 times 2. So this will be -1 minus 6, which is -7. Okay, so we just put a -7 here. And this is our answer. This is the cross product. And of course, the properties of the cross product are yet to be studied and introduced. But that's how we compute it. And it's a good idea to learn this little process and get ready for that notion. Thanks for watching.